Hi there. Welcome to How I Built My Pole Barn Shop. My name is Randy and the puppy is Bailey. And I'll warn you right up front, the first 5 pictures have nothing to do with the build. They are just a way for you and I to be introduced and also allow me a minute to talk to you about planning for the shop before we actually get into the build. This is the first in a 6-part series. This is my story. It's an adventure that I began at age 60. It's an overview of various phases of construction. Not really a step-by-step on how to build. I hope it's entertaining, but at the very least I hope it's informative. Hopefully there's a few ideas that you can use in your project. Having said that, here's the disclaimer. I'm not an expert, I'm not a builder, and I'm not a professional. So if you adopt any idea, be sure to run it by a qualified professional first. We'll get into the meat of the project in just a minute. But first I want to talk to you about the 7 universal steps required for anyone to build. First, you have to educate yourself. Do what you're doing right now, looking at a YouTube. One of the best that I remember seeing when I was looking was by a fellow named Lemmy. His project was called Build a Pole Barn, and he had, I think, 8 parts. It was very good, and I would highly recommend it to anyone. Second, you need to formulate a plan. Write down on paper, okay, it's going to be 60 feet long, 40 feet wide, 13-foot high ceiling, whatever it is, get it down on paper. Third, you need to determine what tools you're going to need. Sometimes they're specialized tools. Sometimes they're tools you're going to have to rent, but you need to figure that out up front. Fourth, you need to visit your building inspector. Find out about zoning, code. You know, can I build on my property? Is it how far off the property line does it be? What's the setbacks? What are the electrical requirements going to be once I get into the building? So you have to figure all that out. Fifth, if you're going to put in a bathroom like I did, I had to go see my health inspector at the here in my county. They have to determine, okay, can you have a septic tank? They'll have to do a perk test and figure out all of that. So that's another thing. The 6th thing is to visit your local power company. How is the power going to be brought to your shop? Is it going to be from my house? Is it going to be another line from the road? Is it going to be to somewhere else? Is it going to be above ground? Is it going to be underground? Who's going to be bearing the cost of all that? Well, you have to figure all that out. The 7th thing is to determine the material needs that you're going to need and start collecting. In my case, I'd actually been doing that for several years, collecting wood, electrical supplies, wire, all that kind of stuff, so that helped cut down the cost quite a bit. So that's it in a nutshell. What follows is a pictorial tour of my building adventure. I hope you enjoy it. And if you have any questions, I'll try and address them in the comments. All right, here we go. Once I had county permitting generally figured out, some general plans drawn, and decided exactly where the shop was going to be located, I was ready to get rolling. I hired a local man who owned a bulldozer, and even though the site didn't need a lot of leveling, the most important thing that he did was to remove that top layer of grass and living matter. As most of you probably know, if you pour concrete on top of grass, in time that grass and that living matter is going to decay, and it's going to create a cavity underneath your concrete, which in turn will lead to settling, sagging, and ultimately cracking, something you definitely don't want to have happen. Once the site was ready, I drilled holes where each of the vertical 6 by 6 by 16 foot wall posts would be placed. About that time my grandkids came to visit, and of course, like all grandkids, they wanted to be helpful. This was the first hole dug, and you can see the 18-inch auger on the back of the Kubota tractor. It allowed me to dig holes about 4 feet deep. Once dug, I then shoveled a few inches of gravel in the base of each hole and tamped it down with a 4 by 4 post. The idea of the gravel, of course, was to create a place for drainage under each post. This hawk was the first official visitor to my shop. He landed on the first corner post, the vertical post that I had placed in the ground, and proceeded to have his lunch one day. I took this picture and he didn't seem to be bothered one way or the other. He finished his lunch and took off after a while. Before each vertical post could be dropped in the post hole, there was some preparation required for each post. First, I drilled a 1/2 inch hole about 4 to 5 inches from the bottom of the post. And inside that hole, I inserted a piece of 1/2 inch rebar, which was about 12 to 14 inches in length. So it was sticking out both sides of the post, but narrow enough so the post could fit down in the post hole. The 16-foot 6x6 beams are very heavy, so I used my backhoe to lift those and slowly drop them in the hole. Once there, I centered the post and attached sufficient bracing to keep it in place. Next, I mixed and poured a couple of bags of concrete in the hole. The concrete set the post in place and also covered the piece of rebar, which provided an anchor at the bottom of each post. The last step, of course, was to backfill with dirt. Once all the outside wall posts were in place, I trimmed the tops of the side posts to an equal height with the help of a laser level. In this picture you can see I also notched the sidewall post tops 3 inches to allow for two 2x12 top banding boards to be placed side by side and bolted to the vertical post tops. At this point I had not yet notched the end posts. I should also mention that the building was 40 by 60 in size, and each post was 10 foot apart to accommodate the 20-foot banding boards that I later used. In this picture you can see where I was notching out the vertical end posts for the upper banding that would eventually run around the top of the entire structure. The end posts were 20 foot in length while the side posts were 16 feet long. I used a power saw to make the initial cut. Then, as seen here, I used a large 20-inch vintage 1800s hand chisel to finish the notch for a close fit of the banding boards. As you can see, John, as in John Deere, was a big help in giving me a standing work base. Once all the vertical posts were notched, I was able to bolt the upper horizontal banding boards to the post tops. Since the sidewall was 60 feet long, I used 3 20-foot long 2x12 boards placed end to end for the first run, and then I used 2 10-foot and 2 20-foot boards for the second run. The result was that in every place where the banding boards butted together at the ends, a second board covered that seam, making for a much stronger structure. The same process was used on the 40-foot end walls, with 2 20-foot boards butted end to end for the first run, and 2 10-foot and 1 20-foot board making the second run. Each of the horizontal banding boards were glued together and bound by heavy carriage bolts every couple feet. In addition, a 2x4 cap was nailed to the top of both boards, which collectively resulted in an extremely strong structural frame. If you look closely in this photo, you can see I had a 20-foot opening with a steel beam across the top in the side of the building. That was because initially I planned for a large 20-foot door at that spot. However, later I shifted plans and decided a 10-foot door at the end of the building would be more beneficial. At that point I added another vertical wall post in the center of this opening, and it became part of the wall. These two side-by-side photos are kind of interesting. They both show my shop during construction, except that one was taken at ground level by me, while the other was taken from space. One day I was looking online at Google Maps and stumbled on this satellite photo of my property. As you can see, it exactly matches the photo I took near the same time frame, perhaps the same day. In the overhead photo you can clearly see the shop outline as well as my backhoe, even its shadow, parked in the exact same place. Don't get paranoid, but Big Brother is always watching. These were the 40-foot ceiling trusses I had built. I decided to buy rather than build trusses. I've built trusses before and could have built these, but at the end of the day, for what it would have cost to pay for lumber, nails, and then of course the great amount of time to build, it was just easier and probably about as cheap to just have them built by a company that does that sort of work. This is one of the specialty tools I had to manufacture in order to build the shop on my own. The used forklift forks were purchased from a local scrap metal dealer and connected to the front of my backhoe. Then I welded up the remaining framework seen here with a horizontal and vertical pipe to act as a female receptor. They in turn held a 12-foot by 3-inch solid steel round bar, which allowed me to lift trusses high enough to put them in place. The ropes you see from either end of the truss allowed me to swing the truss into place while I was seated inside the backhoe. I also had to manufacture the steel triangular piece you see at the end of the pole. It distributed the truss weight and allowed it to be lifted without breaking. Another extremely important piece of equipment I had to manufacture before I ever started building was the steel and wood scaffolding on the back of my flatbed truck. This allowed me to simply drive the truck under where I needed to work in the rafters, climb up a small ladder on the back of the truck, climb up the second ladder on the flatbed to the wood scaffolding, and finally climb the third ladder on top of the scaffolding up into the truss top. Over the course of the build, I was up and down those 3 ladders thousands of times. In this photo, I was nailing temporary 2x4 bracing to tie the first and second trusses together. Here you can see the third truss after being placed and attached. Because there was no one to assist, each truss was very time-consuming. First, the truss had to be hooked up on the ground to the backhoe, then moved, lifted, and placed. Then 2x4s had to individually be carried up to the top of the truck scaffold, and finally those boards nailed one by one as temporary bracing to keep it in place. While all that was going on, there were constant checks to maintain a level orientation. In addition, the truck had to be moved several times during each truss install to provide a working platform at various locations. I'm not complaining about the work involved, just explaining. When one person does everything, the workload is multiplied exponentially over what it would be if you had helpers. But since I knew that going in, that was not an issue. Another very important innovation that allowed me to install 40-foot trusses on my own can be seen here. I built several steel jigs mounted on long poles which hooked over 2 trusses and kept them in place exactly 48 inches apart. Once I got my first truss attached and perfectly level, each succeeding truss was fairly close in level as well when these jigs were attached. The long poles allowed me to attach the jigs while standing on the ground below. Once attached, they kept the next truss in place, which allowed me time to move the truck scaffold, climb up, and then nail temporary 2x4 cross bracing. Here you can see the 3-inch round stock mounted in the horizontal position on the front of my backhoe. This allowed me to lift straight up and work in close quarters, which was necessary when I put in the last few trusses. There was a real sense of accomplishment when the last truss was finally in place. It was, after all, one of the more dangerous parts of the build and therefore involved a fair amount of nervous energy on my part. It also was one of several defining points where a major part of the build was completed. Not only did it define the shape of the building, but I now had a stable structure upon which to work. With the trusses all installed, the next step was to replace all the temporary horizontal 2x4 roof bracing with permanent bracing. The temporary bracing was merely used 2x4s. Now I replaced those with 12-foot long 2x4s, new ones, in staggered fashion across the roof. I started at the lower edge, of course, and just worked my way up the roof line and then went to the other side. Here you can see all the final permanent roof bracing in place. And also, if you look closely in the foreground, you can see the temporary white Romex power line that ran from my garage out to the shop. It was a glorified 400-foot extension cord, but it did provide 120-volt power to run saws, drills, and other light equipment during the build. Because of the long run, the amps were not peaked, but I was careful not to burn up any motors. Again, this was a great sense of accomplishment when that particular part of the job was finished. One of the last parts of the roof skeleton was installing the fascia boards on either end of the roof. With only one person, this again required some innovation. I had to build these simple temporary 2x4 braces connected to the underside of the 2 in-building trusses. They in turn held the fascia board in place until it could be attached with nails. Once the fascia board was permanently attached, I simply slid the temporary holders out of the sheet metal holders under the trusses, and the job was done. If you liked this video, gleaned a few ideas, and want to see how the build proceeded, please hit the like button and go to part 2 of how I built my pole barn shop. Remember, before adopting any idea, be sure to run it by a qualified professional. And if you're contemplating a project, good luck, and thanks for watching.